Hello everyone. So in the last video we discussed the basics of how caching is used in system design, and today we will be discussing the four major cache patterns which you should know while you are preparing for your system design interviews. So the first one is cache aside, which is called lazy loading. And what happens in this is that you have an application server where you have implemented an external cache somewhere like a Redis or Memcached. Okay, now what happens is that first of all your application checks the cache, and if the data is there then it returns. If it is not present, then it fetches it from the database as a fallback. With this, it also stores it in the cache and return it to the user. So it's a both-way operation, right? Uh, the cache side only caches the data when it is needed, and the purpose of this is that it keeps your cache lean. The downside is that it adds an extra latency. Why it adds extra latency? Because let's suppose if a value is not present inside the cache, so it is going to ask from the database, and then once it is going to grab the data from the database, then it is also going to store this in the cache, and from the cache you are getting the data, right? So that's why it causes the extra latency in your application, right? Now the other pattern is the write-through caching. The write-through caching is basically the application writes only to the cache, and then the cache synchronously writes to the database before returning to the application. What does it mean is that the application server, like let's suppose you are building any application, e-commerce application, hospital management, and once you write a data to the database, so this data is not directly written to the database. First it is written to the cache, and from this cache it is written to the database. So synchronously the data is written to the database. In practice, this requires cache implementation that supports write-through, like caching library with the data store plugin. So you have to write some sort of an extra logic to make sure that from cache you are synchronously writing your data to database. Uh, you should also know that Redis itself does not natively support write-through, so as I said, you have to implement this strategy yourself while writing an extra code. Okay. With this, you should also know that the write operation, let's suppose you are writing something to database, so this operation won't be completed unless your cache is also not updated. So if that part is not updated, so the data won't be written to your database. And this trade-off is slower because the application must wait for both the cache update and database write to complete. Okay. Um, when you should use this, you should only use this when reads must always return fresh data, and your system can tolerate slightly slower writes. So this is the important part where you should basically use this pattern. Okay. Another one is write behind caching. In write behind caching, the application writes only to the cache. The cache batches and writes the data to database in asynchronously in the background. So here in write through caching, we were synchronously writing to database, while in write behind, we are asynchronously writing the data to database in the background. So what happens is that your application server only talks with the cache. Okay, it doesn't know anything about the database, and your cache is used to read the data, and your cache is used to write the data. Okay, this makes writes very fast, but introduces risks. For example, if the cache crashes before flushing the data, you can lose data. So this is only best for workloads where occasional data loss is acceptable. Okay, and when you should use this, you should use this when you need high write throughput and eventual consistency is acceptable. Okay, by high write throughput, you means lots of people are trying to, like, have a write operations on your application. Okay, then we have the read through caching, and with read through caching, what happens is the cache acts as a smart proxy. Your application never talks to the database directly, and on cache means the cache itself fetches from the database, stores the data, and returns it. This is a read equivalent of write through. In both patterns, the cache acts as an intermediary that handles database operations. Read through manages reads, write through manages writes, and systems often combine both patterns. What happens is that it is basically the read equivalent of write through, and it works the same way that it accesses the cache, and if the data is not available, then it reads it from the database as a fallback. Okay, but as a fallback, it reads it inside the cache. Okay, and from the cache you get the data. So this is how, like, it is managed. Okay, now what we have is that in this pattern, read through caching, the CDNs can be used with this pattern, because when the CDN gets a cache miss, it fetches from your original server, cache the result, and returns it. So but for application level caching with Redis, cache aside is far common. So this is how it is used. Now we have understood, like, four different principles. That is, like, we have, like, write through caching and write behind and read through caching. What happens when we have limited memory and we need a strategy to decide which entries we need to remove? Like, cache is stored in your temporary memory, your RAM. So what happens if that cache takes lots of space in the RAM? So how you will manage it? Then we have, like, different policies. The first one is least recently used. This means that an item which is not accessed for longest time. So in a linked list, if an item is not used for a long time, so what happens is it can be removed in a constant time. In the least frequently used, what happens is, if any item, we maintain a counter for each key, and we see that that particular item counter is not frequently used or having lowest frequency, so we decide that this item must be evicted from the cache. Now the first in first out has this concept where the oldest item in the cache can be removed, right? It can be implemented with simple queue, but it ignores usage pattern. And the last one is time to live, and time to live is that we specify an expiration time for each key and removes entries which are old. So let's suppose if we specify that an entry should live for like 1 minute. So after 1 minute, that specific entry will be removed from the cache. Okay. So these were like four major principles which are used to like for cache eviction policies. Now we have some interesting caching problems we need to discuss where it like makes our system faster, but sometimes it introduces new failure modes in our system. And how we are going to tackle this is what we will be discussing. So the first problem is cache stampede. Cache stampede is something which happens when a popular cache entry expires and many requests try to rebuild it at the same time. There is a brief window, even if only a second, where every request misses the cache and goes straight to the database. Instead of one query, you suddenly have hundreds of thousands which can overload the database. Um, for example, we have a home feed with TTL of 60 seconds. Okay, this home page feed can be of any website. We will see that it is the home page of a popular newspaper, and we are caching the news for like 60 seconds. Okay, now the cache expires after 60 seconds and hundreds of users simultaneously try to access your application server to watch the news. Now this fresh news does not exist in the cache, so we have a cache miss. Then these 100 users will have simultaneous 100 times request hit to the database, and the database will be overwhelmed with all the requests coming from like 100 users. So this will cause like spike in your traffic. Okay, and also it is going to put a lot of burden on your database. So how can you handle this? You can handle this with request coalescing. In this, only allow one request to rebuild the cache while others wait for the result. This is the most effective solution. Like 100 users try to access your application server to watch the home page feed. And now you just give access to one user to update the cache, and the rest of 99 users should wait until the cache is built. This way you can like stop the traffic to get high, also like stop the database to have like major cascading failures. The second one is cache warming, where you refresh the popular keys proactively before they expire. So we can like put up a logic here somewhere in our application where time to live is 60 seconds, and if the cache expires, then automatically that home page feed is loaded with new data. So this helps us in TTL based expiration, and if we invalidate cache on writes instead, warming does not prevent stampedes. What does it mean is that um, also in our logic, if that cache is expired, or some sort of logic invalidate your writes, then it does not like prevent someone, because the rest of 100 users will still try to access the data, and data won't be available, and hence we will be like major spike in our traffic. So I think the request coalescing is the most effective solution to handle this cache stampede, right? With this, we also have some problem in caching. This is the important one, the consistency. The consistency is basically, I will give example that let's suppose you have a website where a user updates their profile picture. Now you have implemented caching in your system. The new value is written to the database, but the old value might still be there in the cache. Okay. Now, when that user is trying to see their outdated profile picture, new profile picture, they will just see their outdated profile picture. Okay. And why they will see their outdated profile picture? Because the cache is not updated. Okay. Now we can handle this with like three different techniques. One is cache and validation rights. Now if you upload a new picture, just delete the cache entry after updating the database so it gets repopulated with the fresh data. You can also introduce show time to lives for state intolerance. Let's say just stall the data for some time. Okay. Like it's just a user profile picture, like it's not the end of the world, so let's slightly stall the data live temporarily. And I mean, it's going to update for like, after some time. But if the user just wants their fresh and updated profile picture, then this one is like, you should be going to use. Now, lastly, we have something like hotkeys, and hotkey is in a cache entry that receives a huge amount of traffic compared to everything else. What can be the example? The example can be, let's suppose you are building a Twitter and someone or everyone is viewing Taylor Swift profile picture. Now the cache for her user data may receive millions of requests per second, and that one key can overload a single Redis node even though everything is working correctly, right? Millions of users are trying to see the Taylor Swift new picture, so it can overload just one key inside your cache, and this is by definition called a hotkey. How we can handle this? We can replicate hotkeys, store the same value on multiple cache nodes, and load balance reads across them. We can add a local fallback cache, keep extremely hot values in process to avoid pounding Redis. Also, we can apply rate limiting, so it slows down the traffic pattern on specific keys. So we can handle this with these three main techniques. So this was the end of discussing various techniques where we can use caching in our application and also solve different problems. I hope you guys have got the idea, and if you have any question or you have some doubt and want to clear something, so please feel free to leave a comment and I will try to answer you there. Thank you for watching this video and have a nice day.